Okay, hi and assalamualaikum. So today, our team will present lab 4 for activity 1. Here we can see there's two circuit, namely electropneumatic system circuit and electrohydraulic circuit. For your attention, this is sorry, this is the pump. This is the air pump to amplify and channel the air to the mechanism, and this is the water pump to pump water through this mechanism, this piston. Okay, for the both simulation, when we for the both simulation, when we start, we push the button, the piston will move from the right to the left, like that, and the air will go out from here. Same with the hydroponic circuit, is the same. Only the water will get, okay, the piston will move, the water will return to its original place. Okay, we look for the question. Okay, for the question, describe the difference between electropneumatic and electrohydraulic system. For the electropneumatic, the pressure system use the wind or the air to flow. But the electrohydraulic system, pressure system use liquid flow. And this electropneumatic system is designed for open system, and this electrohydraulic system is designed for the closed system. And lastly, the electropneumatic system is an easy piston operation that was widely used. And for the electronic hydraulic system is a hard piston operation. Okay, for the next question is describe an industrial application for electropneumatic and electrohydraulic system shows in figure 1. Okay, for electropneumatic system, industrial conveyor, and we also can see this system in nail gun. And for electrohydraulic system, for the hydraulic pressure, and we can see at the garbage lorry also, because the water will come back to the original storage. Okay, we continue with lab activity 2. Thank you. Okay, hi and assalamualaikum. Okay, so today for the lab 4, the second activity for the simulation, when we start, we can see that this that wind pass here and continue to move upwards, and the piston will move to the left. And when in this circuit, we can see there is wind passing here. There is wind passing here. So when we just press the push button on this S1, we will able to see the piston move to the left and to the right like this. In addition, we can see IB1 and IB2 alternately open and close. Okay, next for the observation, the question is state the name of the component IB1 and IB2. The name component of IB1 and IB2 is a limit switch. Number 2, briefly discuss the function of IB1 and IB2 in this circuit diagram. If you look, this is a limit switch, and this IB1 and IB2 will alternately open and close, and the current will flow, and the piston will be go to the left and to the right when the S1 is closed. Okay, next for the next observation, during this simulation, a symbol with an arrow always appears next to the components in the electrical diagram. Describe what do you understand when you see the symbol. Okay, if you look at K2 and IB1, we have one arrow here. Also at IM1 and K1, we have this arrow. Okay, the function of the arrow is to the current flow. If you look, this is the red line. This is we call the perfect current flow. When we start, push S1 button, okay, the current flow will alternately change from this to this, from this to this. If you look, this is the perfect current flow, and this one is not a perfect current flow. Okay. For the question, discuss the importance of component A. This is a component A. This is a component A for industrial application. Okay, the importance of this component A is to make sure the wind is clear in this pneumatic system, and it also to lesser the usage of the power because it use a high pressure. And the last one is to increase the rate of this component. Okay, that's all for lab for activity 2. We continue with lab for activity 3. Thank you.
Next, activity number 3 for the lab 4. Okay, then I have two diagram, pneumatic diagram and electric diagram. Okay, we'll see what happened. I push this S1 push button. Okay, I will explain what happened in this pneumatic diagram. The air for the input will flow to the 1-4 line and to the expand port and push the piston, and then air for the input flow to 1 to 2 line in valve and to the retract port and push the piston back to the original position. Okay, I will explain about what happened in this electrical diagram. When we push the S1 push button, the current will flow to the C1 and to the K1. Okay, the current also flow to I1 B1 and to the relay K2. After that, this relay contact K1 will close and this relay contact will close too, and the current will flow to 1M1. Then the current will flow to 1B2 and close, and current will flow to the relay K2. Forget K3, and then after that K3 relay contact will close and the current will flow to 1M2 and flow to the C1 counter, and the counter will start counting. And then you can see this process will happen repeatedly. Okay, that's all. Thank you. Next, for the observation number 1, tabulate the list of components used in figure 3. Okay, this is component used in figure 3. Compressor air supply, air service unit, 5 wave valve, double acting cylinder, distance rule, electrical connection 34 volt, electrical connection 0 volt, relay, brake switch, detent switch make, magnetic proximity switch, relay, magnetic proximity switch, relay, make switch, valve solenoid, make switch, valve solenoid, relay counter, and push button make. Okay, next. For the observation number 2, explain the function of F2. Okay, here we can see S2. The first function is to reset the counter. Okay, this counter is 0, and then we push S2 push button. Okay, the counter will reset to the what we set for the counter. Okay, this function will happen to the S2 to reset the counter when the S1 push button is in open condition. When we push the S1, it will make the second function for the S2 push button. Okay, here you can see when we push the S1, the second function of S2 is to make the process happen repeatedly, but not the reset to the counter. Okay, that is the function. Next, for question number 1, the position of 1B1 and 1B2 in figure 3 is different from figure 2. By referring to component A is mag switch and B magnetic switch. Both start particle for 1B1 and 1B2 in figure 3. Okay, the answer is yes, both start particle for 1B1 and 1B2 in figure 3. Same component A and component B. Okay, this is figure 2. This the difference is 1B1 and 1B2 right here, but in figure 3 1B1 and 1B2 is right here. It is different, but the function is the same. Both are scan this piston move right and left. Okay, when 1B1 is in left position or origin position at expand what 1B1 is in close position. Okay, this, and 1B2 is in open position. When this piston is like 1B2 here, okay, you can see 1B2 is closed and 1B1 is open. The component A, component B has the same practical and the same function. Okay, that's all.